Okay, now we're going to move on to the collective head helicopter I was just describing. This is my now this helicopter is radically different from what you just saw, or my other helicopter if you're not watching these in order. This is a Falcon 3D. It was a helicopter that came out, I think, around 2004, early 2000s, I think. I can't remember exactly. It's an electric helicopter. That is, it uses an electric motor. That's what this thing's about. It's a brushless electric motor, which if you don't know what brushless means, it means there's no brushes. It's just a magnetic core on the armature surrounded by 3 coils with a controller that actually shifts those magnetic coils on and off to cause the rotational force to take place, and the feedback to tell the controller what's doing actually comes from the coils itself. So it's kind of like it's a very interesting technology. If you're not checked out on brushless motors, they're really fascinating. Anyway, use a brushless motor, heat sink, receiver. Here's the main battery pack. I think it's about a 1300 milliamp lithium polymer pack. That's the gyro I was just talking about before, how modern helicopters have gyros. It uses some kind of a angular momentum device in there. I think it's some kind of solid state thing. They used to have gyros, again, on those other early helicopters I was talking about. They actually had little spinning wheels, little motors that would spin actual wheels inside. I mean, it's really old school gyros. And those were, they were using those back in the 70s and the 80s when helicopters were really kind of a fringe area where you really had to pretty much build them yourself from scratch. But anyway, this is the gyroscope that controls the tail rotor. And the reason you need to control the tail rotor is without a gyro, there's not too many humans can react fast enough to keep that tail under control. I'll describe flying a helicopter in just a minute, but kind of keep that in mind. Receiver down here, motor spins this main gear. It also has this secondary gear which is tied to another drive gear for the tail. I'm doing the tail the same way. Tail is there's an exposed open gearbox. You can see the mechanicalness going on there. There's also a slider arrangement that lets you adjust the pitch of the tail. That's by operating the rudder control. I mean, if you don't know, the idea is tail counters the torque of the main rotor. The main rotor is going to be wanting to spin this way, which means if you think about it, that means the helicopter is going to be wanting to fight that and spin this way, because it's just the way it is. If you ever held a motor, and if you ever grabbed a little motor and turned it on, you'd feel the twist of it. Well, it's trying to twist that way. So what the rotor does is it blows air that way and forces it back this way. And if you want to turn this way, you make that tail pitch, you increase that tail pitch and it blows harder. If you want to go this way, you decrease it and let the torque take over, or even go a little bit further and actually pull it around a little. You usually don't have to worry about it. There's more than enough torque to spin this thing around. But that controls this direction, which is called the yaw of the helicopter. So you've got a tail rotor, slider assembly, collective head on the tail rotor. Got the rotor actuates the push rod. Let's see if I can make that work. You can see this thing. It's really not a good idea to do this. I'm not going to do that. I'll end up stripping gears or something like that. It's got, I didn't talk about this very much, just touched on it briefly. This is a collective head, which means these are not connected solidly. They can operate together on a collective method where they both increase or decrease their angle of attacks to increase or decrease the lift of the helicopter. It also has, I didn't talk about this at all, it has this called a swash plate. And this swash plate changes the cyclic nature of the blade, so as it progresses in a circle, you can increase the lift on this side of the helicopter and decrease it on this side, and that will make the helicopter roll this direction. You can do the opposite and roll that direction. You can change the lift of the helicopter so that it pitches forward, it pitches back. That's called cyclic controls or cyclic controls. I'm not really sure which is correct. All helicopters essentially, well, except for the really cheap things, all helicopters have a cyclic control for pitch and roll. The yaw function is taken over by the tail. And the swash plate is what transmits all that information from the servos through a ball bearing attached plate. It's able to let the top part of the bearing spin with the little connections going to it, while the bottom plate stays fixed and is attached to the servos. Whoever designed this, I don't know if it's Sikorsky or Ivan Sikorsky or whoever came up with this whole uh, arrangement. Those guys were geniuses back in the day to figure this out. A little bit on helicopter flying. Basically, it wants to beat itself to death. So they require a lot of maintenance. You got to really stay on top of them. They want to vibrate apart. There's a lot of stuff about balancing and making sure everything's lined up right and all your angle of attacks are perfect and trimming it out. Blah blah blah. What's it like to fly a helicopter? Well, if you've flown an airplane, I'll give you an analogy. Imagine a soup bowl, a perfectly round soup bowl, shaped like this. Imagine putting a marble in the middle of the soup bowl, and that's an airplane. That marble wants to staying in the middle, the bottom of the soup bowl in the middle is flying and without any, just flying along. So in other words, you upset the soup bowl, the marble wants to go back to the middle. That's what it's like to fly an airplane. All you gotta do is I'll just tilt the soup bowl over this way, the plane goes that way, and I'll stop and it returns back to normal flight. That's the flight characteristic of a typical airplane. Take that soup bowl, turn it upside down, put the marble on top now, put it around my knuckle there. The marble does not want to stay in the middle anymore. In fact, the marble will do everything in its way to get off the top of that soup bowl now. So your goal is to keep balancing and moving constantly to try to keep that marble right on the top of the soup bowl, right on the top of that round soup bowl. It's that unstable. These things do not want to fly. They require constant attention by the pilot to keep them in the air. So it's very different from flying a well trimmed out airplane with a proper amount of dihedral and wash out in the wings and all that kind of good stuff, and to get it properly trimmed. Well, basically fly itself. You put in a dive, you release the controls. They'll typically tend to pull up, get themselves out of a dive. Helicopter, no. Helicopter wants to crash. I mean, that's its primary mission in life is to crash, and it's up to the pilot to do everything in his power to keep that from happening. Every fraction of a second, he's got his hands on a stick. You take your hands off a stick on a helicopter, it'll be in the dirt before you can say boo. Now, the exception to that is coaxial head helicopters. Coaxial head helicopters, which I'm not aware of any full-scale helicopters. That maybe I'm not much about them, but they are inherently stable because they're almost like two gigantic gyroscopes. The problem with coaxial head helicopters, I sure as heck wouldn't want to get one on a windy day. The reason being, when you have something as unstable as this, it also means you can react quickly. So if you have a gust of wind or something happens fast, if you're a good pilot, you can recover from it instantly and have no problem. If you take an inherently stable plane that hasn't got and it doesn't have a lot of control authority, I guess you should add that to it. When you have that, then the lack of control authority means a good gust of wind pushes it off and bang into a tree or boom to the side of the house, something like that. This thing can deal with a gusty day because it has a lot of control authority and you have a lot of say-so as to where it goes. You just better give it the right information. If you have a bad windy day and you give it the wrong information, forget about it. It'll beat itself to death and be like some dead animal flopping on the ground. Been there, done that. Anyway, that's my other helicopter. I got one more to show you in here, and I got a flight of it going on. I haven't flown this one in a couple of years, so I'm just kind of getting back into it. That LMH I worked on, that other helicopter had a lot of gunk and goo. I had to clean it up. That's the other advantage about electric helicopters, is the fuel helicopters, be it glow fuel or gasoline powered, they're always dirty. I mean, you got to really spend a lot of time cleaning them up if you're good about that kind of stuff. If you're not good about that kind of stuff, you'll end up getting I got some rust on that main shaft. Didn't notice that before. You have to clean up those glow-powered helicopters all the time. Otherwise, the oil that's spewed out from the motors gets everywhere, dries up, cakes up, turns into varnish, and next thing you know, you'll have a gummed-up works. And again, helicopters require free moving parts. You don't want to be having anything sticking. I imagine real helicopters or full-scale helicopters if you prefer. I can see why those things must cost a bundle, not just to buy, but to maintain, because proper maintenance on these things requires an awful lot of time. I mean, I don't know, maybe it's for every hour flying, you should be maintaining it several hours, maybe 10 hours of off time, just going through and making sure nothing's falling apart. That's an exaggeration. But if my life depended on it, you betcha, 10 hours for every hour in the air at least. I don't know if that's got anything to do with the truth. You know, I haven't even checked into it. That's just me off the top of my head. But I know you better make sure everything's right, because like I said, these things want to crash and they want to vibrate apart. That's just the bottom line. All right, anyway, that's the Falcon 3D helicopter, electric powered.